If you're wondering, how do we know how large is this space of the ocular reticle, the little ruler in your eye? Then the answer to that is we measure this. And the way we measure is, instead of putting a sample there that you don't know the size on the stage, you put a little thing called a micrometer, which is a very tiny ruler. So this thing, we actually know the spaces, so or the size of the spaces. Let me tell you that these spaces here, each space of this guy measures 10 micrometers. Okay, so that little u is for micro. It's the shorthand for mu, that the Greek letter. Okay, so we know that on the micrometer, each space is 10 micrometers, and this thing is a ruler that physically you know the distance. This one is a physical ruler on your eyepiece, but these spaces depend on how large these are, depend on which objective lens you are using. So in your table 2 in the lab manual, you will see that it says that 4 ocular spaces correspond to 10 stage spaces. So somebody compared this ruler to this ruler, and they saw where they coincide, kind of like there are these 2 cars in front of you, and they are like their lights are blinking, and at some point they're synchronized. So maybe you're comparing the frequency of blinking of this car, frequency of blinking of this car, and then when they coincide, you're like, oh, okay, 5 blinks of this car or 4 blinks of this car was 10 blinks of this other car. So now you want to know how many of these blinks are there in each of these other ones. So the way you would set this up is you go, there were 4 ocular spaces. They correspond to 10 stage spaces. And I told you that on the stage, so there were 10 just because 10 corresponded to 4, and each of these 10 measures 10 micrometers. So this 10 micrometers is fixed no matter which objective lens you are using. This, if you had a ruler small enough to measure this, this is how big it is. Okay, so let's simplify this over here, which should be for ocular spaces. They measure 100 micrometers. The reason why I know it's 100 micrometers is because the 4 ocular spaces correspond to 10 stage spaces, and each of those 10 stage spaces measure 10 micrometers. So I multiply that 10 by that 10. And then what I want to know is how big is this in micrometers? So I go, my question is, how about, I'm going to write like this. How about 1 ocular space? How many micrometers is that? So we're going to cross multiply, and you're going to end up with 100 divided by 4, which is 25 micrometers. So that's how we know that when we are using and this relationship that I just showed you is on your table, and on table 2, and this is when you are using the 4x objective. So when somebody was looking at this micrometer using the 4x objective, this is the relationship that was drawn. Each 4 of these were 10 of these, and therefore how big is each one of these? And it's 25 micrometers. You don't have to do this reticle calibration anymore. It's only one time. So this is called reticle calibration. So once somebody has done this work for you, all you do is you use the table that the person gives you, as in when you use the 4x objective, the space is 25. Then you have to, or if you're the person calibrating, move from 4 to 10. Then you have to compare, this guy now will grow, right? It looks bigger because this is under the lens. So this blue line will look bigger. And then you see where they correspond and you draw the next relationship, which is in your lab manual. Good?